Good morning students. Hess's law. What is Hess's law? Hess's law is the enthalpy change in a chemical or physical process is same whether the reaction or the process is carried out in one step or in several steps. Okay. It is the enthalpy change in a chemical or physical process is same whether the process is carried out in one step or in several steps. Example, let's take an example. In the first case, carbon plus O2 gas gives carbon dioxide gas. This is delta H. The enthalpy change is delta H. This is the reaction. It can take place in two intermediate steps. Okay. So, plus half O2 gives carbon monoxide gas. This is delta H1, and the next step is CO gas plus half O2 gives CO2 gas. Okay, same reaction but takes place in two steps. Okay, so according to Hess's law, delta H, the enthalpy change of the reaction or the standard enthalpy change of the reaction will be equal to the sum of the standard enthalpies of these intermediate reactions. That is delta H1 plus delta H2. Okay, this is the relation. Okay. Next, applications of Hess's law. First point, determination of enthalpy of formation. So, it is helpful to calculate the enthalpy changes of reactions which are experimentally not possible. Calculate the enthalpy of reaction of certain compounds which are not experimentally possible. So, these compounds cannot be directly synthesized from its constant elements. So, what happens? So, by using Hess's law, we can indirectly calculate the enthalpy of reaction. Example of some compounds C2H6, then C6H6 are examples. So, we can indirectly calculate their enthalpy of reaction by using Hess's law. Okay. Second application, determination of enthalpy of reaction. Okay. So, this Hess's law also permits to treat thermochemical equation as like algebraic equations. So, like that, the same like algebraic equations, we can solve this equation. So, example, calculate the enthalpy of reaction of this following reaction. That is, carbon monoxide gas plus half O2 gives CO2 gas. We have to calculate the enthalpy of reaction. Okay, it is given carbon plus O2 gives CO2. This is the first equation. Delta H is equal to minus 394.7 kilojoule. Okay, this is first equation. Also given carbon plus half O2 gives carbon monoxide gas. Here delta H is given. It is minus 110.5 kilojoule. This is second equation. Okay. Now we have to calculate the enthalpy of reaction using Hess's law. Okay. Two reactions are given. So first we have to reverse second equation. What happens? CO gas gives carbon plus half O2. Okay. So while reversing, the delta H sign changes. So 110.5 kilojoule. Okay. Now we can add 1 and 2. Add 1 and 2. Now what happens? 1 plus O2 gas. This is the LHS side. Now here the LHS side is CO gas. Okay, gives. Here RHS, CO2 gas plus here carbon plus half O2 gas. Now we have to add delta H. Delta H will be equal to minus 394.7 plus 110.5. This much kilojoule. Okay, now what happens? This gets converted into half O2 here. So, equation becomes CO gas plus half O2 gas gives carbon dioxide gas. Okay. The equation, we got the same equation here. So, now the delta H, we have to add these two and we will get the answer minus 284.2 kilojoule. So, like this, we can calculate the enthalpy, of reaction of a particular reaction using Hess's law. Okay. Next, third application. Determination of enthalpy of transition of allotropic forms. Determination of enthalpy of transition of allotropic forms. Okay. So, this Hess's law is also very helpful to calculate the enthalpies of transition of allotropic modifications such as graphite to diamond, rhombic sulfur to monoclinic sulfur, etc. Okay, let us take an example. Calculate the enthalpy change for the allotropic transformation from monoclinic sulfur to rhombic sulfur. Given S rhombic plus oxygen gives SO2 and its delta H is given, that is minus 295.1 kilojoule is given. Then similarly S monoclinic plus oxygen gives SO2 gas. Okay. Here also delta H of R is given. minus 296.4 kilojoule. Okay, these two equations are given. Okay, now what we have to, let us take this as 1 and this is 2. Okay, first we can reverse this equation. Equation 2, reverse 2 and add with 1. What happens? So this gets reversed and LHS become RHS, RHS become LHS, and this sign is reversed. That is, sign changes to plus sign. So now we can write S rhombic, and now we are adding plus O2 gas. This RHS become LHS plus SO2 gas. Okay. Similarly, here S monoclinic plus O2 gas. Same LHS. Okay. Here this is SO2 gas. Now we are adding these two. This sign is reversed. So delta H of R will be equal to minus 295.1 plus 296.4. We will get minus 1.3 kilojoule. So this much will be the energy. Energy during the transformation, this much. This is an exothermic reaction from S monoclinic to monoclinic sulfur to monoclinic rhombic sulfur. Okay, so the energy change, that is delta H of R, is minus 1.3 kilojoule. This much energy is released during the change. Okay.